The Boeing 787 Dreamliner was not just another passenger jet. It was Boeing's answer to a major question facing airlines in the early 2000s. How do you make long-distance flying cheaper, more flexible, and more comfortable without simply building a bigger airplane? For decades, airlines had often relied on hub-and-spoke networks, funneling passengers through major airports before sending them onward. Boeing believed the future could look different. Instead of forcing passengers through giant hubs, airlines could use a smaller, efficient wide-body aircraft to connect more cities directly. The 787 was designed for that idea. It promised long range, lower fuel burn, and enough capacity to make thinner international routes profitable. But the Dreamliner's story is also a story of ambition, delays, technical risk, and manufacturing complexity. It became one of the most advanced airliners of its time, but getting there proved far more difficult than Boeing first expected. The roots of the 787 go back to a different Boeing concept, the Sonic Cruiser. That aircraft was meant to fly faster than conventional airliners, offering airline speed rather than maximum efficiency. But after the economic shock that followed the early 2000s downturn, airlines became less interested in speed and more focused on fuel costs. Boeing dropped the Sonic Cruiser and shifted toward a more conventional but highly efficient design. On January 29, 2003, the company announced the 7 × 10⁷, the project that would become the 787. The letter E was widely associated with efficiency, which captured the central promise of the program. This aircraft would not win attention by breaking speed records. It would win by reducing fuel burn, lowering operating costs, and opening new routes. Boeing formally launched the program on April 26, 2004, after All Nippon Airways placed an order for 50 aircraft, giving the jet a powerful start. At launch, Boeing targeted a major performance improvement, about 20% less fuel burn compared with older aircraft such as the Boeing 767. That number mattered because fuel is one of the largest costs in airline operations. A 20% improvement could change the economics of a route, turning marginal city pairs into realistic non-stop services. The 787 was designed to carry roughly 200 to 300 passengers over distances up to about 8,500 nautical miles, depending on variant and configuration. That put it in a sweet spot for long-haul point-to-point travel. Airlines could fly between cities that did not have enough demand for a much larger aircraft, while still offering intercontinental range. This was one of the Dreamliner's defining ideas, not simply carrying more people, but carrying the right number of people over very long distances with far less fuel. The Dreamliner's most famous engineering feature is its extensive use of composite materials. It became the first major airliner with an airframe primarily made from composites rather than traditional aluminum. Composites can be lighter, resist corrosion differently, and allow engineers to design large structural sections in new ways. This helped Boeing pursue the aircraft's efficiency goals. The 787 also made greater use of electrical systems, replacing or reducing some traditional pneumatic systems used on earlier jets. In simple terms, Boeing tried to make the aircraft more electric, more efficient, and more integrated. Externally, the 787 is easy to recognize once you know what to look for: the distinctive four-window cockpit shape, elegant raked wingtips, and chevron-shaped edges on the engine nacelles. Those chevrons help reduce engine noise, which is important for airports and communities as well as passenger comfort. Powering the Dreamliner are 2 high-bypass turbofan engine options, the General Electric GEnx and the Rolls-Royce Trent 1000. These engines are central to the aircraft's efficiency story. High-bypass turbofans move a large volume of air around the engine core, producing thrust more efficiently than older designs. But the 787's efficiency did not come from engines alone. It was the result of a full system: lighter materials, improved aerodynamics, advanced engines, and modern onboard systems working together. This is why the aircraft was such a leap for Boeing. It was not just installing a new wing or a new engine on an old formula. The Dreamliner combined many new technologies at once. That gave the aircraft its promise, but it also increased development risk. When a program changes this much at the same time, problems in one area can ripple through the entire schedule. One of the most consequential decisions behind the 787 was how it would be built. Boeing relied heavily on subcontractors around the world, more than it had on previous aircraft programs. Major sections and systems were produced by suppliers in different countries before being brought together for final assembly. The idea was to share costs, tap global expertise, and speed development. In practice, the global production model became one of the program's biggest challenges. Coordinating design, manufacturing, quality control, and delivery across a huge supplier network is extraordinarily difficult, especially on an aircraft filled with new technology. On July 8, 2007, Boeing rolled out a prototype 787, but it lacked many major operating systems. The rollout created excitement, yet it also foreshadowed trouble. The aircraft looked ready to the public, but behind the scenes, the program still had a long way to go. The 787 was originally targeted for introduction in 2008, but the schedule slipped repeatedly. The aircraft finally made its maiden flight on December 15, 2009. That flight was a major milestone, but certification and delivery still took time. The Dreamliner received type certification in August 2011, clearing the way for airline service. The first 787-8 was delivered in September 2011 and entered commercial service with All Nippon Airways in October 2011. For ANA, the launch customer, the aircraft represented years of waiting and a central part of its long-haul strategy. For Boeing, it was a moment of relief after one of the most difficult development periods in its commercial aircraft history. The Dreamliner had gone from bold promise to delayed reality. The question now was whether it could deliver the operating performance airlines had been promised. The original version, the 787-8, is about 186 feet long and typically seats around 248 passengers, depending on airline configuration. Its range is about 7,305 nautical miles, giving it the ability to operate many long-haul routes with a relatively modest passenger count. This made it attractive for airlines testing new non-stop city pairs or replacing older wide-bodies. The 787-8 was followed by the stretched 787-9, which is about 206 feet long and can typically carry around 296 passengers. It also offers slightly more range, around 7,565 nautical miles, making it one of the most versatile members of the family. The 787-9 entered service with All Nippon Airways on August 7, 2014. For many airlines, this became the best balance of capacity, range, and economics, and it played a major role in the aircraft family's commercial success. The largest member of the family is the 787-10. At about 224 feet long, it can seat around 336 passengers in typical layouts, but its range is shorter, about 6,330 nautical miles. That trade-off is important. The 787-10 is not mainly about flying the longest possible routes. It is about carrying more passengers efficiently on medium to long international routes where demand is stronger. It entered service with Singapore Airlines on April 3, 2018. Together, the three main variants gave airlines choices: the 787-8 for smaller long-haul markets, the 787-9 for broad long-range flexibility, and the 787-10 for higher capacity routes with slightly less range. This family approach helped Boeing appeal to many different airline business models. A carrier could use the same general aircraft family across multiple route types while benefiting from common training, maintenance, and operational familiarity. Despite its advanced design, the early years of the 787 were marked by serious technical problems, especially involving its lithium-ion batteries. These batteries were part of the aircraft's broader move toward more electrical systems, but early operations revealed risks that demanded immediate attention. Some aircraft experienced onboard battery fires or overheating events, raising safety concerns across the global fleet. In January 2013, the United States Federal Aviation Administration grounded all 787s. This was a major event. An entire modern airliner type was temporarily removed from service until a fix could be approved. Boeing redesigned the battery system with additional containment and safety measures, and the FAA approved the revised design in April 2013. The grounding damaged confidence, but it did not end the program. Instead, it became a reminder that innovation in aviation must always be matched by conservative safety validation. The Dreamliner also faced significant production and quality control challenges years after entering service. From 2019 onward, manufacturing issues led to inspections, rework, and a slowdown in production. Deliveries were almost completely halted from January 2021 until August 2022. For airlines, delayed deliveries can disrupt fleet plans, route launches, and aircraft retirements. For Boeing, these problems added financial strain to a program that was already extremely expensive. The 787 program has cost Boeing tens of billions of dollars, with estimates around $32 billion. Analysts have debated how many aircraft Boeing needs to sell to break even, with estimates ranging from roughly 1,300 to 2,000 aircraft. These numbers show the scale of modern airliner development. Even a successful jet can take years, sometimes decades, to fully justify its investment. The 787's safety record was also brought back into public focus after the first fatal crash and hull loss involving the aircraft, Air India Flight 171, on June 12, 2025. A preliminary report issued on July 12 by India's Aircraft Accident Investigation Bureau did not recommend any actions to Boeing or to 787 operators. In aviation, early reports are carefully worded because investigations take time and must separate evidence from speculation. The event nevertheless became part of the Dreamliner's history, because any major accident involving a modern airliner receives intense scrutiny. Aircraft safety is not judged by one event alone, but by design, operations, maintenance, oversight, and investigation findings over time. For the 787, the crash added a somber chapter to a program already known for both technological achievement and repeated controversy. As of July 2026, the Boeing 787 program had received 2,453 orders and delivered 1,299 aircraft. Those figures capture the contradiction at the heart of the Dreamliner. On one hand, it suffered delays, battery problems, quality issues, and enormous development costs. On the other hand, airlines kept buying it because the core idea worked: an efficient, long-range, mid-size wide-body could reshape international flying. The 787 helped make non-stop routes more practical, gave airlines flexibility, and pushed aircraft construction toward composites and more electrical architecture. Its legacy is not simple. It is not just a triumph, and it is not just a cautionary tale. The Dreamliner is both a bold technological leap that changed long-haul aviation, and a reminder that every leap in aerospace comes with risk, cost, and consequences that can last for decades. If you found this helpful, please like this video and subscribe for more explainers.